Welcome to Land Eco Lightning Talks and Thinking Like a Landscape with Dr. Kevin McGarrigle. In this 8-part series on the natural range of variability concept and current departure, I discuss the origins of the concept, definitions and alternatives, applications, and important considerations in the implementation of the concept. In this talk, part 2 of the series, I will define natural range of variability and talk about some alternatives to the range of variability theme. Okay, let's get started. Let's begin with a definition of NRV. I pulled this definition from the Landris et al. 1999 seminal publication in Ecological Applications on NRV that I discussed in the first talk in this series. The definition is as follows. NRV refers to the ecological conditions and the spatial and temporal variation in these conditions that are relatively unaffected by people within a period of time and geographical area appropriate to an express goal. That's a mouthful, but it's necessary because it expresses a number of key attributes to the NRV concept. First, it refers to any ecological attribute. There are myriad ways to describe and measure the ecological system, and NRV applies to any single or combination of ecological attributes. Second, it refers to the spatial or temporal variability. So the range of variability here is both in space and or time. Thirdly, it talks about a defined reference period. That means the period in time within which variability is being expressed. And as we talked about in a previous Land Eco Lightning Talk series, things like natural range of variability and any measured characteristic of landscape pattern is scale dependent in both space and time. Therefore, one must specify the reference period, the period in time within which NRV is to be expressed. Similarly, it talks about a defined geographic area for the same reasons that these things are scale dependent in space as well as time. And then lastly, that it's goal oriented. And this echoes back to the previous talk in the Working with Landscape series on the importance of stating a clear pattern, process, goal, or question to guide the definition of a landscape and to guide the landscape analysis. And this applies to NRV as well. So it's important to recognize that there are several key attributes to the NRV concept. I also want to talk about variations on this range of variability theme so we can put the NRV concept into broader perspective. There are numerous variations on this theme, and I've listed several of them here. I'll go through them briefly here, but then we'll look at how these concepts relate to each other visually in the following slides. The first is the contemporary reference conditions, or CRC approach. And this refers to contemporary variability across reference sites. So this is within the contemporary landscape addressing variability across space. The second approach, historical reference conditions, or HRC, is similar in that it refers to the spatial variability across reference sites, but in this case for a single historical snapshot of the landscape. The third is historical range of variability, or HRV, and this refers to the temporal variability, that is the variation over time for any given location. And these three approaches, the CRC, the HRC, and the HRV approaches, are ways to address the natural range of variability, or NRV. And this is quite simply the variability in the system that is unaffected by modern people. We also can think about the modified range of variability, or MRV. And this would be the variability in the system that has been altered by human activity. And then we can talk about social range variability, or SRV. This would be the variability that society finds acceptable or desirable. And lastly, the future range of variability, or FRV. And this is variability in the future determined by both natural and human forcings. So you can see here just from these definitions that there are numerous variations on this range of variability theme, and it behooves us to understand where NRV fits in relationship to these other concepts. And that's best done visually using a Venn diagram. So here, shown in the green box, is essentially a conceptual space representing the variability in one or more ecological attributes of interest that is unaffected by modern people. This is the so-called natural range of variability. And the historical reference conditions, the contemporary reference conditions, and the historical range of variability approaches all are various ways to address NRV. And we'll be discussing each of these three approaches to NRV in great detail in subsequent talks. But think about this green box as representing the full range of variability in the ecological attributes of interest, regardless of how we obtain that. And then if we think about the variability in the system that has been modified or altered by human activities, and that's shown here by the red box. And a portion of that overlays the NRV box, because some of the variability in the system today that has been created through human land use activities is consistent with the variability that would be expected naturally to occur. But of course, we have caused our systems to move outside that natural range of variability in some ways, more so in some cases than others. So a portion of this box does not overlay the NRV box. That is variability that essentially is unique to the system because of modern human activities. And then if we throw on the social range of variability box, we see that some of that overlaps the NRV box, because what society deems acceptable or desirable is consistent with what the system variability would have been naturally. And some of that overlaps the MRV box, because, again, what society seems acceptable or desirable is consistent with what modern human activities have done to the system. But some of that box lies outside both the NRV and MRV box, because some of what society deems acceptable or desirable has not yet been implemented, has not yet been essentially encompassed by contemporary human activities, and would require some additional or new ways or new land use activities that would cause some variability to exist outside those previous two boxes. And then lastly, the future range of variability. It overlays the three previous boxes and also has some unique space. So a portion of that future range of variability overlaps the NRV box. And that's because we would expect some of the variability that would occur naturally, unaffected by modern people, would also persist into the future under most conditions. We also would expect in the future that some of that modified range of variability from contemporary land use activities would also persist into the future. And then we would also find that some of that future range of variability would be consistent with what society deems acceptable or desirable. But there would probably be some portion of that variability that is kind of outside the range of natural variability, outside the range of what modern human activities do to the system, and outside of what society deems as acceptable or desirable. And that would be the portion of the FRV box that essentially does not overlay any of the other boxes. So this Venn diagram is useful in seeing how NRV is really just a subset of these other range of variability concepts and ideas. And the size of the NRV box relative to the MRV, the SRV, and FRV box is something of great interest to us. And the smaller the NRV box is relative to FRV, perhaps the less useful it becomes as a guide for future management. So if we think about this Venn diagram as this series of overlapping boxes, where we have the NRV overlaid by the MRV, overlaid by the SRV, overlaid by the FRV, We can think about each of these partitions of this Venn diagram as kind of representing kind of a unique part of the variability in the system. So the first box up here that I've highlighted would be the natural variability that is lost forever, either because human activity prevents it, future conditions don't allow it, or society doesn't want it. It's that part of the NRV, that part of the variation in the natural system that is not consistent with modern land use activities. It is not consistent with what society finds acceptable or desirable, and it's not likely to occur under future conditions. So it's essentially variability that will be lost forever. You can also think about this partition in the Venn diagram. And this would be natural variability that is feasible given human activities and future conditions and is deemed acceptable or desirable by society. So it's the part of the future range of variability that encompasses what we expect to have occurred naturally in the absence of human activities. It's consistent with NRV. But it's also consistent with what modern human activities and land use practices are able to achieve. And it's also a variability that society finds acceptable or desirable. This box, however, is what we might call unnatural variability, variability we would not expect to occur because of human activities. It's unnatural variability caused by human activities, but it's feasible given future conditions and deemed acceptable by or desirable by society. So again, it's that variability in the future that is outside the natural range of variability, but certainly feasible given modern land use activities, and that society finds acceptable or desirable. This box would also be unnatural variability, that is, it's outside the NRV box, but requires new human activities, new land use practices to create it, because it's not within the range of variability that contemporary or modern human land use practices create. So we'd have to create new land use practices to create this variability. But it's conditions that are deemed acceptable or desirable by society. And then lastly here, we have the portion of the future range of variability that would be deemed unnatural and unacceptable or undesirable, but feasible given future conditions. So this is the part of the variability that is not natural. It's not easily created by modern land use practices. Society does not find it acceptable, desirable, but it's likely to occur because of kind of unknown, unforeseen, novel future conditions. So we can also label these boxes on the bottom left, where we have the overlap of all four of these range of variability ideas, is we have desired conditions that come at no cost. This is the future range of variability that is consistent with the natural range of variability and does not require any human land use activities, new or old, to maintain it. So it's desired conditions that come at no cost. The second box would be desired conditions that come at some cost, because this variability does require modern land use practices to create that variability that is outside the natural range. The third box would be desired conditions that come at great cost. This is because these are conditions that do not occur naturally. They have not been generated through modern land use practices. They are feasible, but with modified or more intensive land use practices that probably would require a much greater cost to achieve. And then the last box would be undesired conditions that come with an unknown cost, because these are conditions that are essentially unknown or unknowable until we see what the future brings with us. These are the kind of the unknowns and the surprises of the future. All right, the take-home message from today is that natural range of variability is just one of several range of variation concepts. NRV focuses on variability unaffected by modern people. But in practice, it must be understood and applied in the context of variability caused by modern human activities and with regards to future environmental conditions and societal demands and desires. Well, this is Dr. Kevin McGarrigle signing off from this episode of Land Eco Lightning Talks. I hope this talk has been helpful, and I hope you join me for my next lightning talk. In the meantime, keep on thinking like a landscape.